Hi everyone, welcome to this video on how to solve computer science coding problems. And the reason why I'm doing this particular video is that I've had this question multiple times from many of my students earlier that although they have the tools for a programming language, for example, let's say Python, and like using all the lectures and or using a book, but they struggle when they actually start solving a problem. And in order to address this issue, I decided to do this particular video, and obviously, this is for beginner programmers. In this video, we'll talk about the challenges that you face as beginner programmers. So basically, you know the tools, the syntax of a coding language, but you are struggling with problem solving, right? And I will, in detail, talk about my own strategy that I use for problem solving. That involves a general framework for problem solving, obviously, some ways of dealing with some common issues, and essentially my 5 step process. So, if you follow this 5 step process for every problem that you encounter in coding, most likely you will get through that, right? So, let's look at it. Some of the common issues, if you just started programming and you learned a new language, are that when you look at a problem, you're not sure where to start, right? So, this is like the most common issue, and especially when you're looking at bigger coding problems, right? So, if the problem is big, you do not know where to start, right? Sometimes it seems extremely overwhelming, and sometimes you might have some thoughts about how to solve this problem, but then you have trouble converting your thoughts to actual code, right? And this actually is the biggest hurdle for any programmer. And we will today talk about how to overcome that hurdle, how to be better at programming in general, how to get started, first of all. Okay, so let us begin. And as I said, I'll talk through my own strategy, which I implemented and I found it quite successful. I've also communicated it to other students, and they've also found it pretty successful. And so I'm describing that here. Okay, so what is step one? Step one is to always read the problem at least 4 times. And as you can see, I've emphasized 4 times or even more. And that's absolutely fine. If you're putting in some time and effort right at the beginning, you will be saved from a lot of time later on, right? So read the problem, reread the problem, and especially if the problem is big, keep reading it again and again, right? The issue that I've seen initially is that reading the problem once only can give you a false notion of maybe thinking that you understand the problem, but actually you don't, right? And sometimes the issue is reading halfway and assuming things because you've looked at a similar problem before, and so you miss out on the important details, right? And the important part that I already talked about it, taking extra time in the beginning will minimize the extra effort that is required later on, maybe in debugging or maybe at arriving at the real solution, arriving at the actual solution, right? Now, within this step, something that I always follow is that after the fourth read or even after the third read, I try to explain the problem to myself and maybe saying that out loud, right? So maybe if you have a friend, you can say or describe the problem out loud. That's one way. If you have nobody, just say that to yourself because you're sure. Make sure that you understand the problem well, right? So this step is extremely important. This is my step one. In my strategy, step two is writing down on a piece of paper. Extremely important, sometimes overlooked, sometimes not paid a lot of attention by many programmers, but I think this is the most important step in our entire strategy. If you do not write down the steps before actually jumping onto your IDE, whichever you use for your coding, you will encounter issues. So, especially if you're beginning to code, if you're not an expert programmer and you just learned some tools from a programming language and now you're trying to put them to use to solve a particular problem, make sure you write the problem down. Write the problem down and write your instructions down. Okay, so in step two, I'm not asking you to write a program. Instead, you have a problem in front of you, right? And think about this particular aspect. So think about your computer does not understand, let's say, Python, right? But the computer understands English. So the computer understands each and every step that you give to it, right? So think about your computer understanding English and then write down your steps or your solution in English, just like the way you'll give instructions to anybody given a particular task, right? So for instance, if you're writing in English, make sure that you um, break down as much as possible your steps, make them as refined as possible. And as I said, think of this exercise as equivalent to giving instructions of, let's say, making tea to a person who has never made tea before, right? So think of like you're giving instructions to solving this problem to a person who has never solved this problem before, but you know the solution, so you are going to break that down for him or her, right? For instance, as we are talking about tea, let's look at it. Let's say I'm asking my computer to make tea, right? Although sounds weird, but yes. So the first thing you should write down is what is the requirement of your problem, right? What is the requirement? What is the output? What is the outcome? So this is my output or my required outcome: make tea for two people, right? And as you can see in writing the steps, I've broken down the problem into each and every step that's required, no matter how small that step is, right? And then eventually I arrive at my solution, which is when the tea is ready to serve, right? So within the, like, once you're done with this writing process, go back and analyze each and every step. So let's say I wrote the number of steps that are required to make tea, and let's say I forgot to write this particular point, right? Turn on the stove and put the pan on it. Let's say I did not give this instruction at all, and assuming that the person has never done this before, what you'll have eventually is cold water put in the kettle, right? So think of your program. It is similar. If you miss out a step, or if you do not have the order correctly, the outcome, which is like tea for two people, will not come out the way we want it to be, right? So make sure you're giving instructions when you're writing, even in English. It has each and every detailed and um, step and sequence correct. So this is important. So this is step two. Now coming to step three. Step three actually involves improving or improvising on step two only, right? So refine your steps. Start thinking in terms of Python. For example, like I'm assuming that I'll write my program in Python. Start thinking about the tools that are available to you from the programming language you work with, right? So for instance, work through the steps that you listed in two manually. What I mean is that go and create some sample data, right? Go and create some sample data and see how, when you're solving the problem using the steps that you just listed here, whether they work well with that or not, right? And as I said, small sample data should be small so that you can solve that manually, right? For instance, look at a small problem. Let's say I'm trying to find out the smallest number in a list. Let's say, so first step is I'm going to sort it, and then I'm going to find the first element in that sorted list, and so on. So basically, I'll begin with a very small list of, let's say, only three elements, right? So work that out manually, right? And then go in and like work with a slightly more complex data. So maybe take a list of size, let's say 10, right? I don't know, something like that, right? And it is in this step that you're going to think about logically separating things, right? So this is the step when you will think about whether your code requires something like functions, right? Maybe this is your bigger problem, right? And you could actually divide it into smaller chunks. So this is the stage, this is the part where you'll realize that and actually break it down into those parts and decide that you'll have functions for this functionality and you'll have some other function for that functionality and so on. Okay, so this is step three. Step four is the pseudocode. So again, even at this stage, do not get caught up with the syntax. Pseudocode is nothing but a more structured way, and we'll see that in an example of writing all the instructions that you have from steps 2 and 3, right? So more here, we will specify whether we are using a loop or what kind of a data structure are we using, for example, a list versus a string and so on, right? So we'll start specifying those technical terms basically in this particular step, right? So this is the technical terms step or strategy, step in my strategy. And then finally, this is the step where you will move on into your IDE. So notice we spent a lot of time before we moved on to writing the actual code, to writing the actual Python syntax, right? So when your pseudocode is ready, then what you can do is translate each and every line into real code, right? And then and my like added instruction here would be that do it in smaller chunks. Do not write the entire script all together, but rather do it slowly and start checking the values and the code behavior, the outcome with those smaller chunks. Okay, sometimes new programmers will get hung up with the syntax. That's okay if you want to refer to your notes or you want to refer to the material that you have for correct syntax because you're just beginning. So that is going to be an issue, obviously. Okay, so this is the 5-step strategy. Things that you should remember throughout these 5 steps is about testing and debugging. What that means is for every step, even when you were writing instructions in English, also always try to come up with some sample data or some test data with which you can check whether your instructions are going to work well or not, right? So this will minimize the need to actually test for when you actually run your code, right? So test for the algorithm would be create your own cases and check if the solution will work. Test for the pseudocode is going to be think of corner cases, think of different sizes of the data or the input, and then check if the solution work. And then finally, for the actual code, you are going to create some data and test on that. Or maybe the problem itself will specify some test cases, so you test on that, right? Another optional step is if you want to maintain comments, do that. If you want to maintain some kind of an explanation of every step that you took to solve a problem, do that. Okay, so this was the 5-step strategy to solving a problem. Let's actually apply this to a problem. Okay, this is the famous cryptography problem. It is common in most of the computer science courses, and let's read through it. So, a shifting cipher, also called a rotating cipher, if you've seen that before, is one of the simplest plain text ciphers. So it's going to encode, decode your messages essentially. Known since at least the time of Julius Caesar, it takes in a plain text string as shown here. Okay, it's not shown here. Any string, for example, A, B, C, D, right? And it's going to translate into a new string based on a shifting of the alphabet being used. And the basis of that shifting is a sequencing of the alphabet. For example, here, a shift of size 3 or rotating of size 3 is shown here. So as you can see, shifting by 3 means that whatever element is at position 3 becomes the first one, and then this becomes the second one, and this becomes the third one, as you can see here, right, and so on. And the elements that were here went to the back, right? So that's why this is called a rotating cipher. And what this means is that we can encode our messages, decode our messages based on this idea. So if you want to read this problem, take some time, stop here, pause here, and read the problem again. And some more problem specifications are given. So you need to obviously write a program that should prompt the user for encoding, decoding, or quit. And any other command should raise an error. That's fine. If the command is so the first thing that comes to my mind is that I have to do at least 3 operations, right? I have to do 3 operations, and I'm moving towards my step 1 where I'm going to write some sort of instructions for this problem, right? So obviously the program should prompt, which means continuously ask the user something, right? So that's going to be something that I need to remember. And then based on if the user is asking for E, obviously do something, like obviously go and pause the video and read the problem. And the program should not encode any letter that is not in the lowercase alphabet. So we are encoding only the lowercase alphabet, and the rest stays the same. Now, this is the idea that I get in encoding. And then more specifications, if the command is decode, then the program should ask for the string to decode and some word that might exist in that decoding message, right? And then basically we need to find out the shift, like what was that shift that was applied when this was encoded. So there is a separate part for decoding. So if the user says D, I have to do that, right? And then finally, if the user says quit, just stop the program. Okay, so let's apply the strategy. The sample output is given here. So for example, if it was E and this is the message to be decoded, you can see 3 is the rotation, right? And so we get WKLV. So we can quickly look at why this is happening, right? So for the word this, for example, THIS and shift 3, right? If I go here and look at T, and because we have a shifted alphabet already, right? So this is the shifted alphabet. For T, I will get W, right? For H, let me search for H. I should write K, right? So W, K. For I should write L, and for S, I should write V, right? So this will be my encoded message. So that's similar to something we are getting here. Similarly, the rest of it, and we print that message, right? So similarly for decoding, we'll get the decoded message, encoded message, and a word. So based on that word, we'll find out how much the rotation happened here. So those are some of the sample outputs. Let's actually apply the strategy that we just talked about step by step. So I'm going to do that in the next video that's coming up. That's part 2 of this lecture.